Okay, so hello guys, hello everyone. This is our continuation video on the thermodynamics topics. And for this discussion video, we have to fully understand the concept of the laws of thermodynamics. And when we talk about laws of thermodynamics, I have here a specific representation for the laws of thermodynamics. Okay, so if you will not read this article, you will definitely understand the laws of thermodynamics just by looking at this entire picture or seeing a representation. So, pero um, question is, paano mo maintindihan? Because based on this picture pa lang, I have already explained all the laws of thermodynamics. So this amazing image or this amazing representation explains kung ano ga katabo in the concept of thermodynamics. So, question subong, based on what was discussed in a previous nga discussion video or based on sa kita ninyo diri. Um, question is, how many laws of thermodynamics are there? Siyempre, kakakita yun na big word dere, four. So we have four. So well, there are total of four laws of thermodynamics. We have the zeroth law. We have your first law of thermodynamics, your second law of thermodynamics, and we have your third law of thermodynamics. Okay, so amo ni subang focus ng ating nga discussion. I will give you a clear explanation of all of these thermodynamics laws along with a wonderful nga mga examples. And I know, kabay pa matamat naton ma-intindihan ang overall nga concept. I have also discussed some of the tricks para masapos naton ma-recall, kag ma-remember ang mga difficult nga statements of all this four nga mga laws. So in fact, this is the exact trick which makes me remember sang sini nga mga four laws of thermodynamics very easily. So let's get started. Okay, let's start this one with understanding the zeroth law of thermodynamics. This is just very easy. Trust me. I'll explain to you the zeroth law of thermodynamics with this simple nga animation. Okay, so tanawa danay. Okay, so sige. I'll explain this samtang ga-play ang aton animation liwat. Just observe lang anong gakatabo sa animation. Okay, so as a student, you should have one question in your mind. Kabalo ko, ang ngalan sini nga law is zeroth law of thermodynamics. Kalabanan yung mga law is first, second, third lang ari yan nagsugod siya sa zero. We have zeroth law of thermodynamics. So we have here. So it should be like first, second, third, etc. Pero nga zeroth ang ginpangalan. Why is there a zeroth law of thermodynamics? So it was in the year 1935. So it was in the year 1935 when Ralph Fowler was reading a book and he came upon a certain nga text sa libro. Ang nakabutang sa sinanga text is that every physical quantity must be measurable in some numeric terms. Every physical quantity must be measurable in some numeric terms. Okay, take note, sa sinanga time, no one was knowing about the term temperature before the year 1935. Hindi pa sila aware sa concept of temperature. So, and main thing, tanan-tanan nga laws of thermodynamics, your first, second, third nga law of thermodynamics were already discovered before 1935. Okay, in 1935, it was Fowler who discovered the title Zeroth Law of Thermodynamics, kag ang thermal equilibrium na concept. Fowler realized that this phenomenon, sang thermal equilibrium, is very important kag kinanglan siya dana i-discuss before prior pagid gani sa understanding of first law of thermodynamics. So, kay kun lang tawon naton ang concept nga discover ni Fowler, diri ginpakita. This law shows the presence of very important property, which is temperature. Dari makita sa zeroth law of thermodynamics ang concept of temperature. Nga kung tanawon naton, based on a specific na concept of laws of thermodynamics later on, kung i-discuss na, it's all about temperature man Japon tanan. So, kinanglan hambal ni Fowler dapat amo ni danay ang tun-an before mag amo ni danay ang dapat maintindihan before ang concept of first, second, and third law. Okay, so but sa amo na nga time hambal ko or hambal ko gani kagina sa discussion is that na-discover na dalang first, second, and third law. And damo-damo na sa mga libro, damo-damo na sa mga articles nga na-publish nga ang topics is on the first, second, or first law, second law, and your third law of thermodynamics. So now, changing the number of these three laws, pwede mag-create sang dako-dako ang confusion. Thus, hambal ni Fowler, hindi niya na pag-change. Hindi na pag-change ang first, second, and third law. Thus, he come up with the zeroth law of thermodynamics. Zero. Halin sa zero. 0, 1, 2, 3. So, both silingon, mas una pag siya because zeroth law of thermodynamics. So, question subong is, what is the zeroth law of thermodynamics? Okay, again, so, napa-observe ko na ni kagina sa inyo sa babaw. So, subong, just look at the representation. Ano ang kakakita naton? Consider three bodies here. We have body A, B, and C. Okay? Based on the thermodynamic nga definition, if two bodies A and B are in thermal equilibrium with third body C, then body A and B are also in thermal equilibrium with each other. Okay, so kabalo ko medyo budlay siya intindihan because of the technical terms ni Gimplastard. But let me explain to you in a simple way. Just see this uh, animation. Consider, may ara kita tatlo ka body dere. We have your body A, body B, and body C. All of these bodies are initially at different temperature. Hindi sila pareho sang temperature nga gina-consider. So body A and B are separated from each other. So kung makita niyo diri sa aton nga representation, and both of these bodies are in contact with the third body, which is so in contact sila. Okay, take note that after quite some time or after a few minutes, body A will be in thermal equilibrium with your body C. Okay, so and same way, body B, maparis-paris naman siya, ma-thermal equilibrium naman siya with your body C. Okay? So, depende kung hindi ang mauna sila nga duwa. But, equilibrium ang A to C, may equilibrium man ang B kag C. So, after this condition, if A and B are kept in contact with each other, so we have here, so then there will be no heat transfer between them. This means, kung itupadon ko si A kag si B, this means nga both of these bodies, A and B, are now in thermal equilibrium with each other. So, kung makita na naton kagina sa aton nga color change, sa aton nga animation, sa aton nga animation, I mean, you will get the exact idea. Nagpareos na sila tanan color. So, wala ta diga endorse sa isang kandidato. Pero kay amo ginayang color, wala ko may makita ang animation. So we have this one. Okay, so thus, kung tanawon naton sa sini nga representation, if body A is in thermal equilibrium with C, and body B is in thermal equilibrium with body C, then mahambal naton that your body A and B are also in thermal equilibrium. So again, kung equilibrium si A kag C, equilibrium man si B kag C, but siningon si A kag si B, equilibrium man sila nga duha. So we have sa amo na nga concept of your equilibrium. Pwede ta mahambal that the temperature sang A is equal to your temperature of C and temperature of B is temperature equal sa temperature sang C. That means ang imo nga temperature of A is equal to temperature of B sa aton nga representation. Okay, so amo lang man na ang gina-plus-star naton sa sining law. So question is, what did you find from the zeroth law of thermodynamics? Okay, so ang bali sa aton nga emoji, I found a property, temperature. So, temperature. Yes, ang nakita naton, if we study the concept of zeroth law of thermodynamics, we understand the fundamental property of temperature. This physical property tells us whether two bodies are in thermal equilibrium or not. So, if the temperature of the bodies are the same, then the bodies are in thermal equilibrium with each other. So, if the bodies or temperature of bodies are the same, basically is. So then the bodies are in thermal equilibrium with each other. Okay, so amo na siya ang pinaka-explanation git of your zeroth law of thermodynamics. Simply, I just want to say that your zeroth law of thermodynamics helps us in finding the temperature of the object or a certain nga body. So, application of your zeroth law of thermodynamics includes the following. So, ginagamit natin ang zeroth law of thermodynamics in number one, measuring your human body temperature. Okay? So, zeroth law of thermodynamics ang gag-govern sila. Measuring the atmospheric temperature. That is zeroth law of thermodynamics in Japan. We have your temperature measurement for industrial application. That is governed by the zeroth law of thermodynamics. We have temperature measurement in air conditioner. That is zeroth law of thermodynamics. We have temperature measurement in your refrigerator. Thermodynamics man na Japan. Ang ara-ara. Okay? Application in food processing ng mga industries. So that is on the concept of zeroth law of thermodynamics. Okay, so there will be a more detailed information about temperature measuring instruments, or kung paano ang temperature related to the zeroth law of thermodynamics, what is thermal equilibrium, and how it is related to zeroth law, and many more nga pwede niyo makita damdamon na sang articles nga ara sa internet nga pwede niyo basahon. But we will have a specific topic nga ang aton nga focus is on the zeroth law of thermodynamics, and I do hope nga makaya ta pa na siya ilang buton all throughout this term or this semester. So now, let us discuss sang nabilin nga remaining three laws of thermodynamics in a simple way. Again, hambal naton kagina, we discussed or ang ato na found out nga concept sa zeroth law of thermodynamics is the concept of the importante katama nga physical property, which is the temperature. Since naintindihan ta na or nabalaan ta na ang concept of temperature, gamiton ta na in understanding the first law of thermodynamics. Kay just observe kung ano ang kakita ninyo sa sininga animation. Okay, so after watching this animation, base napanumdum ka mo nga may Christmas celebration, may fiesta, may sinulog na, kay may pa-fireworks. Pero ang gusto ko di point out is not that one. Kung nakita ninyo, what happens kung mag-burst na ang crackers or mag-burst ng fireworks, for example. Okay, based on this animation, your chemical energy are converted into your heat energy plus your sound energy. So, it is converted pakadto sa mechanical sa sound energy kag heat energy. Okay, another here, I have another nga representation or another example. So, are, we have this one. So, guess what happens here? So, ang aton nga electrical energy is converted. Kung isaksa ko na ni, the aton nga electrical energy is converted in mechanical energy of the fan. So, another one, we have here another nga example. Okay, so this one. So, you can see here the conversion of your electrical energy into heat energy. The coil becomes hot because of your electric current. So, ang coil naton mainit siya because of kung isaksa ko na akon nga electrical energy. Okay, so we have here. So this one. So I guess medyo familiar ka mo sa sining example. Wherein ang aton nga heat energy, this one is your fuel. So, ang aton nga heat energy halin sa fuel is converted into mechanical energy. So, converted siya into mechanical energy. So, now let me give you the exact idea about the first law of thermodynamics. So when we talk about first law of thermodynamics, so we are considering that energy can neither be created nor can be destroyed, but transformation of one form into another form can be possible. Again, energy is neither created nor destroyed. It can only be transformed from one form to another. So, mula na ang atong nga first law of thermodynamics. So, this means that the total amount of energy in the universe remains constant. Don't worry, I will explain to you all the concepts of the first law of thermodynamics along with the practical examples occurring in our every daily life. So, I'll also explain to you why this law is also known as the law of conservation of energy. Okay, so take note or kung matandaan natin, we have different types of energy. So we have heat energy. So kung makita nyo, we have also mechanical energy, may mga movement. We have also your chemical energy. So we have your electrical energy and a lot more ng mga pwede natin gamiton nga types of energy. Okay, so all of these energies mentioned can be converted from one form to another. But do you know kung paano ni siya kakatabo or how this will occur? So let us take an example. Example nga sa elementary years pa lang nato na intindihan ta na or sa elementary years pa lang naton gin-discuss sa aton. Let's take an example which we already know. So we have this one. The process of photosynthesis. Anong nakatabo dire? So the heat energy of the sun is absorbed by the plants and it is stored sa aton nga mga sa aton nga mga plants in the form of chemical energy. So it is a conversion of heat energy into chemical energy. Okay, so wala ko naging detalye anong natabo sa photosynthesis. Amo lang man ang aton nga concept. Gin-convert niya ang solar energy into chemical energy. Okay, so we have here, so balikan tani, ang ating naging plus star kagina. So you have already seen the fans, grinders, mga mixer machines, etc. in which the rotor or the motor rotates with the help of electric power. Thus, ang aton nga electrical energy is converted into mechanical energy. Kagina, star ko man ang ari nga representation. So, that what type of energy conversion is taking place here? So, we have already seen this example sa previous naton nga section or sa previous naton I mean nga discussion kagina. So it's a conversion of electrical energy into heat energy. This is how the first law of thermodynamics or law of conservation of energy appears here. Now, uh, if we consider this, so there are two more important classification of energy na pwede naton i-consider. Main classification of energies include the kinetic energy kag potential energy. This one, probably na-discuss nyo na sa physics, kag medyo naintindihan na. But when we talk about your kinetic energy is the energy which an object possesses due to its motion. Okay, if any object moves with same or with a same nga velocity, then it possesses your kinetic energy. Okay? So, kung may movement or may motion yung katabo, may ara siya kinetic energy. Okay, so we have here. So, okay, so if any object is at some height from a ground level, then it possesses your potential or energy in it. So now let us see how these two energies can be converted from one form to another. So, hambal naton kung ara siya at a certain height from a ground level, may ara siya potential energy. That means, for this one, may ari potential energy ang aton nga stone dire. Okay, this boy is holding a stone. So in which at some height, that means it has some potential energy right now. So ano ang matabo if the boy released the stone? That means the stone starts to move downward. So since may movement nga nagkakatabo dire, this is now kinetic energy. Thus, the potential energy of the stone is converted into its kinetic energy. Here, also, the energy is conserved. The energy is just converted from one form to another, from potential energy into kinetic energy. Okay, so again, if balikan ta ang concept of thermodynamics. So, thus, according to the concept ang thermodynamics or law of conservation of energy or first law of thermodynamics, I mean, the energy remains conserved. So, many energies and a uh, energy conversion nga katabo sa aton environment. And I have here one simple picture to illustrate sang sina ang mga energy conversion. So hindi ko siya ma-present sa isa lang ka picture. But we have or nga isa lang ka pagpakita sa inyo. But amo ni ang gakatabo overall sa aton environment. So many energies in this very single picture lang nga gakatabo. So we have conversion nga gakatabo dire. Okay, there is a conversion of one form of energy to another. Okay, so okay, I hope you, based on this representation, based on this figure, or based on this picture lang, I hope you have understood every single conservation of energy from one image itself. So, plastar ko lang niyo, ipakita ko lang na sa inyo, send ko lang ang kabilugan ng picture para makita nyo ang totality sini. Kaya hindi ko siya mapakita ang bilugid because dako ang ating picture. So, now, let's see the equation kung paano nato ni-understand mathematically ang concept or ang equation of the first law of thermodynamics. Okay, so energy ang aton nga gina-consider diri hambal naton kagina, energy can neither be created nor destroyed, but transformation of one form into another can be possible. Okay, so before kita magsugod sa concept or understanding the laws of thermodynamics, let me tell you my personal story. So when I was a student, I faced many problems in understanding the mathematical form of first law of thermodynamics. But then, syempre, medyo nabulayan ka. I read from books, internet, and I also learned from many nga mga teachers nga ginpatudloan ko. Now, I have found the best way to remember this equation of the first law of thermodynamics. So, in fact, the example which I have mentioned in this discussion video so makes me remember the first law very easily. And this will work for you too. I am sure of that. So here, I will explain you the entire concept hidden in the equation of the first law of thermodynamics. So, in the previous natin nga discussion, so in the previous natin nga lecture video, we saw that the first law of thermodynamics or sa babaw natin nga discussion kagina is nothing but a law of conservation of energy. So, amo ni ang aton yung considering explanation. Energy can neither be created nor destroyed, but transformed from one form into another. So, now, para sa aton nga mathematical form, the equation of your first law of thermodynamics includes heat, syempre. We have also your work. We have your internal. And amo na ning gamiton naton nga mga variables in order to understand this. In terms of heat, work and internal energy, the statement definition of first law of thermodynamics can be stated as. So, amo na ni subong ang aton nga definition of your first law of thermodynamics. The net change in total energy of a system is equal to the heat added to the system minus the work done by the system. So amo na ni sa ang aton nga definition subong. Kasi hambal mo sir mapahapos ang pag-explain. So I know it's difficult to understand the statement. So I have prepared a very simple example for you. So let us proceed further para mas maintindihan ta ang concept of the first law of thermodynamics. Based on this picture, we can see here that the boy is taking the energy drink, which is having a Q amount of energy. Q amount of energy. That means Q amount of energy is entering his body. So, Q amount of energy ang gininom niya. So, next one. So, now, kung makita natin sa sininga representation, this muscular boy has gained Q amount of energy and now he is ready to do any form of work. So, and right now he is having total energy E1 kung nakita niyo din sa representation. So, gin-represent ko lang siya as E1. Okay, next, let us proceed. So, we have this one. Now, this boy, nag-spend siya sang W nga amount of representation, W amount of energy in doing some work. He loses some energy and now finally his total energy reduces into E2. So amo na ni subang ang value or amo na ni subang ang atong representation sang nabili niya nga energy because gingamit niya ang certain amount of energy sa pag-ubra niya sa work. So, in the representation, may ara kita, your Q is the inlet energy nga nagsulod sa body, W is the ang nagwa nga energy because gingamit niya for certain work. We have una niyang energy, total energy during initial state, total energy during the final state is E2. So, we have that ini nga mga terms. So, kung tawon naton, here, this muscular boy gains Q amount of energy and she spends W amount of energy. So, nag-intake siya sang Q and nagpagwa siya sang W. So, we can say that the change sang kabilugan ng energy of the body is Q minus Q minus W. So this change in total energy is nothing but. So ang ini nga change sa total energy is equal to the change sa siniman nga energy. So the change sa energy sa initial kag final state sang lalaki or sang aton boy of consideration, which is equal to your E sub 2 minus E sub 1. So final state minus initial state. So that means, so we have this representation. Okay, so ang pasulod niya nga energy, gigamit niya nga energy is equal to change sa total energy nga na-experience sang boy. Energy niya sang initially siya nag-perform sang work, initially in total minus or ang final I mean niyang energy after niya nag-perform work minus your initial energy. That is the net change in the total energy. Final minus initial. So, amo ni ang aton nga representation. Now it is easy for us to understand the statement definition of first law. So first law of thermodynamics so states that so the net change sa aton nga total energy of a system is equal to your heat nga gin-add naton sa system minus some work done by the system. So now let us discuss the effect of heat and work on the total energy change of a certain system. Okay, so when the system gains some heat, so kung tanawon ta, kung mag gain siya or magdugang ang heat sa aton nga system, then the value of the net change sa aton nga energy. So kung magdugang ang heat, syempre madugang man ang aton nga energy. Uh, another nga consideration, kung damo ang work nga gina-perform sa imong nga system, then syempre madako ni ang value sa aton nga W. Thus, ang aton nga total energy or the value of the change of the total energy also decreases. It is just very simple. Lantawon ta lang ang representation natin through this equation. Kung madugang ka sa Q, madako niyang value. Kung magdugang ka sa W, madugang obra or madamo ang ginaobra nga work, then magamay ang change sa imong energy. Okay, so more detailed information about sa heat, work at the same time sa internal energy nga change. So, our sign conversion for heat and work, perpetual motion, limitation of your first law of thermodynamics, and many more. Discuss na siya naton separately kung focusan ta na gid ang concept of your first law of thermodynamics. Okay, but for this one, hasta lang tatidanay, you have your first law of thermodynamics. So this is it for now. Thank you. Stay safe. God bless.